Hello everyone, welcome back to my channel. This is gonna be the second video of my channel. So I found another interesting problem, and this problem actually also involves the Cauchy-Schwarz inequality, just like my last problem. So the problem is that given the equation x squared plus y squared equals 144. Well, this isn't really an equation. It is, but it's more like graph, right? So if you plot this on a graph, it's gonna be an oval that probably looks something like this. Or a circle, but it's probably gonna be a circle. Yeah, it is. But the problem is that if you're trying to draw a rectangle in here, what is the largest perimeter that it could have? So question is largest perimeter. And you can actually use another inequality to solve for the area, which is what I'm going to do in the next video. So for the largest perimeter, we know that this, let's first find out what the perimeter is going to be in terms of x and y. So the perimeter is going to be 2 times this for the top side, and then 2 times y for this side, and then 2 times that whole thing to complete for the complete perimeter. So this is y, this is y, this side is gonna be 2y, this is x, this is x, this side is gonna be 2x. So the perimeter equals to 2 times 2x plus 2y. Right? So that equals to 4 times x plus 4 times 4 times y. Okay, so now let's do a review of what the Cauchy-Schwarz inequality is. I'll just call it CS inequality. So Cauchy-Schwarz inequality. I'll actually not use the sigma notation for this one, just so it's more intuitive. So let's say x1 squared plus x2 squared plus all the way to xn squared times y1 squared plus y2 squared plus all the way to yn squared. That's going to be greater or equal to x1 y1 plus x2 y2 all the way to xn yn, that whole thing squared. And this part only equals when x1 over y1 equal to x2 over y2 and so on. And if it doesn't satisfy this condition, it'll always be greater than this part over here. So, this part we know that we can just substitute this in. There is no reason for us to do this, but we can just try different things out and see where it gets us to. So, because we know obviously this equation is going to be helpful to us, we can just try and see what we get by plugging this in. So x squared plus y squared, and without the equal sign, and then we can do, so we want x with degree 1 and y with degree 1 on the right side, so we can do 1 squared plus 1 squared. That is greater or equal to x plus y squared. And the left side, this is going to be 144 times 2 is greater or equal to x plus y squared, and 288 is greater than x plus y squared. Okay, so let me just try to explain this one more time. So x squared plus y squared, we put it in here, this part, and then because we want the right hand to have x plus y or something like that, we can just put 1 here. So this way, x times 1, this term will only be x, right? So then 144, and we can just plug this value into here. 144, or in here, 144 times 2, that's going to be greater or equal to x plus y squared. And so x plus y is smaller or equal to 12 root 2. And because we want this to be as small as, we want this to be as great as possible, because it's the largest parameter, we set it equal to 12 root 2. Well, then the answer should be pretty clear now. It's just 4 times x plus y, which equates to 4 times 12 root 2, which is 48 root 2, and that's the answer. And for the next video, we will be solving for the largest area. Okay, thanks for watching.